In this video, we're going to be talking about a particular type of transformation called a translation. So let's start with some vocabulary. A transformation is a change in the position, shape, or size of a geometric figure. And a translation is a slide of a geometric figure. In other words, a translation is a type of transformation. And we're going to be talking about several different types of transformations in Topic 9, but we're going to start with translations. And when I say translation, you can just think sliding the figure around the graph, okay? An image is the result of a transformation. So we start with the original, and its transformation is known as its image. And we indicate an image by using a prime. And let me show you what I mean by that. Let's read the question and I can show you what I'm talking about. Which graph shows triangle DEF and triangle DEF its image after a translation? And as you can see in this second triangle DEF, you can see these small marks. And those small marks are known as primes, and the primes are telling you that you're looking at the image of the figure. And the triangle is used to indicate that we're talking about the shape a triangle. So here you can see three examples, and the darker one is the original, DEF, and the lighter one, using the prime, and hopefully you can see those primes, is the image. All right, and we're asked which of these is a translation. So a translation, what does that mean? Well, that means that you slide the figure and that every point on the figure is the same distance and in the same direction from the original. Let me show you what I mean by that. So I'm going to start counting. Here I have F, and at this point or vertex of this triangle, let's see how far it is to the prime, to the image of F. And we're going to go over 1, 2, 3, 4. So that would be a slide of that vertex 4 to my right. Let's go to E and see if it's also 4. It's 1, 2, 3. Okay, so from F to F prime was 4, and from E to E prime was 3, so this is not a translation. Let's try the second example. Here, vertex F, let's go over and count. It is 1, 2, 3, and 1 down. So in other words, F got slid, if you will, 1, 2, 3, and 1 down. All right, let's try vertex E and see if it follows the same pattern. E is moving 1, 2, 3, and 1 down. All right, we're 2 for 2. And let's try D to D prime. That's moving over 1, 2, 3, and 1 down. So I know that this, graph number 2, this is showing the triangle DEF and its image, triangle DEF, with the primes. So that makes sense. This triangle apparently got slid over 3 and down 1. And I can go here to this triangle in the third example, and I don't think this is going to work. Let's count. We have a slide of 1, 2, 3, 4. And as you can see, it's not just slid, it's actually been rotated. As opposed to these, you can see that E and E are in the same place, E and E are in the same place. But here, E and E are not in the same place. This triangle has actually been sort of flipped. So the answer to this question, which graph shows triangle DEF and triangle DEF its image after a translation, is number 2. All right.